Today we're on location, and today I'm with Thorston Wuest, and we're going to tell you a little different. It's been about 4 years, I think, since the last time I interviewed you, Thor, and I'm really excited to be talking to you on location, but we're on location in a different location. We're not at the same university this time, and what we're talking about now is some new things you're doing. I want our listeners to get to know you, what you're doing, because you're at a different university, you've got some new projects, but still in the same things you've been doing. Our listeners are going to be very excited about that. But what I'm really excited is we're not talking about the future of industry, not theory, but really what the future of industry is really all about. And that's what I like. When people say it's the future of industry, is it theory? It's not theory, but you're really living it. You're getting our students that we're talking about, the future of work, really geared up. Talking about all the things that you and I talked about 4 years ago, really ready for the future, and I'm excited about that. But I want you to talk about what innovation's all about when we talk about what that means, and I want you to share with our listeners what that means. And as a leader in the industry, and now the new director of the USE Center for Industry Solutions, and the professor at the University of South Carolina, welcome to the show.
Thank you so much, Peggy. It's a pleasure to talk to you again after 4 years. Felt like yesterday, but apparently it's 4 years. A lot has happened since then, right, as you alluded to.
Tell us, how did you end up making the trek this way, here to South Carolina? That's where I've been, and it was interesting to find you here, coming from leaving where you were. Tell our listeners, get them caught up to how you ended up making it now to South Carolina, leaving where you were for a professor previously. Why don't you tell us a little bit about the transition you've made, and then we'll talk about the new role that you have here and what you're up to.
Absolutely, happy to. 4 years ago, I was at West Virginia University in the Industrial and Management Systems Engineering program, still doing smart manufacturing and advanced manufacturing research. And then the opportunity arose to join University of South Carolina, which is a university that is growing rapidly, both in numbers of students and in ranking, with a very innovative approach to teaching students first and integrating students from day one into research, which really aligned with my vision of what a university should do, what professors should do. Now, in addition to that, South Carolina, it's a state that is growing rapidly, industry is growing rapidly. I'm originally from Germany, so South Carolina has a lot of German heritage. Carolina Gold, mustard based, because of the German settlers, as I learned after a year and saying how I like the sauce. And people
the accent doesn't give it away.
The accent doesn't, and the name neither. But anyhow, a lot of German manufacturers here, right? Scout Motors, 20 minutes from here, building a $2 billion facility. That is exciting. That is exactly where I see my research having impact, because I always feel engineering, especially manufacturing engineering, needs to be grounded in real world problems, because engineering is not physics, right? It's an applied science. So we have to ground our research in real problems. And real problems, the University of South Carolina did not have an industrial engineering program to date. And it was the most requested major by companies, by parents, and by students that was not yet offered at the university. The decision was made to offer that new major to serve the state as a flagship institution. And initially it was supposed to be a major that delivers value to students, graduates, undergrad students, and does that efficiently under the college, right? And when the opportunity arose for me to join, the vision changed a little bit, and now we're building a really strong program, still focused on student education, but with a full cohort of highly capable and very talented tenured faculty. I was the first tenured faculty that joined. We already hired 2 teaching track faculty, 1 professor of practice, John Pedda. He has 30, 40 years of industry experience, from leading the Six Sigma effort at GE Health to leading an Amazon warehouse and being CEO of an electronics manufacturing company. Right? We wanted a person like that to teach our students what industrial engineering means in the real world, right? And he does fantastic with the students, and students are really excited to learn from his practical experience. We hired another instructor from Clemson University, but we're playing nicely.
I was going to say, that's tricky here in this state.
It is and it is not, and I will get to that in a second. We hired him, he's fantastic, a cyber savant, very dedicated instructor, and right now, this moment, we're hiring 5 additional professors. We're in the process of that. We already have 1 that accepted the offer. We're getting out additional offers, which will make us a really strong department, because we hire very strategically in the smart manufacturing area, right? With different nuances, but all with that central core. because we realized we cannot be a full-blown program like a Georgia Tech from the beginning, because the resources are not there, right? But we can be an extremely strong program in a very core area, smart manufacturing, that aligns with the state and the vision of the state and the university. I think we will make a really big impact in that space. And our program already started last August with 19 students. At the beginning of the spring semesters, we are at 66. The growth is already more than we expected. We had to change classrooms twice already, get bigger rooms, because we didn't expect that growth. The projection for the fall are also, I think, 40% growth over last year. We expect a pretty rapid growth for the program because the state, manufacturing state, needs industrial engineers, right? And that's what our company partners tell us as well.
And it's exciting. Governor McMaster's is retiring. The lieutenant governor that you have right now is very committed to helping the next generation see the future. She's said it, I've interviewed her, and she's been very excited about what we can do. And this is a state that's been very committed to that vision in a lot of ways. And you talked about Scout Motors and all of that, and BMW and the other companies that are here that are very committed to that. Let's talk about that a little bit. And we joked about the competitiveness just from a college sports situation. It's very interesting moving here because we've been from Chicago, where I've come. It's been on the major side of it. Here it's on the college side. I've learned a lot about that. But what specific sides of this, when you look at what you want to do from a research, you and I have had discussions many times about smart manufacturing, the idea of getting the next generation to understand the innovation side of things. But we have to have the individual people, us, at the center of this as well. It can't just be about technology.
Absolutely.
Any of the research that you do, the emerging technology, the researcher, whatever, what areas do you expect to focus on? Because I think that's going to be critical. I know you've talked about some of the professors that are going to be a part of this, but we have to have the students at the center of that. They have to see what they can contribute and where they are most excited about, because if they're not excited, you know that even though you have growth, that growth is going to get stymied if they don't feel excited about what the future is going to bring for them.
Absolutely, and I have too many things to say to that, so I will just start real quick with the neighbor in the north, with Clemson, right, the rivalry. And for industrial engineering, before I even joined here, I talked to the department chair of industrial engineering at Clemson, and he was super supportive. We realized that industrial engineering and smart manufacturing is an area where we can all grow together, right? Because high school counselors, unfortunately, don't know enough about this exciting area to counsel students to choose that career. When we work together, we can grow the whole pie, right? In both
Larger pie.
Yeah. And I visited them 2 weeks ago to give a seminar, and what I learned makes me even more excited, because industrial engineering typically has 3 different areas of focus, right? Manufacturing, OR, and human factors. And while, of course, each program covers all on the teaching side, but they normally have strength in certain areas as a program. And Clemson has a big strength in OR and human factors, while we consciously decided we want to be strong in manufacturing. Technically, we don't even compete in the same field with Clemson, so that makes our collaboration even more appealing to both of us. I think we can help the state together to grow in that space. Bringing back the human and the student in the center, right? That comes, the second opportunity, what convinced me to come down here is the Center for Industry Solution. As you probably saw when you drove down here, we recently got named by Alex Molinaroli. He was the former CEO of Johnson Controls and gave a very generous gift to help the university and help the college to grow. And he, being a seasoned leader, industry leader, it came with some expectations, right? Good expectations. For example, he realized that students, especially engineering students, tend to have a very good background, technical background, math, thermodynamics, CAD design, whatever their major is, they're very well prepared on the technical side. But what business schools do better is prepare the students for presentation, salesmanship, all these other skills that are extremely important when they hit the job market, right? And so we're working very actively on catching up to the business school in that sense to help our students not just be technically great, but also grow on the side, the personal skill side that will help them get a solid footing in their careers from day one. And the Center for Industry Solution is one piece of that puzzle. There's multiple pieces with the Career Center and class curriculum changes, but the Center for Industry Solution, the idea is to be the front door to industry for the college for multiple reasons. One, We're the flagship institution, so we want to help South Carolina and South Carolina industry, especially smaller companies as well. And second, prepare our students for the real world, right? As you mentioned, they have to be in the center. They have to know what's going on, how they can actually make an impact, not just apply technology. And one vehicle that we're working on implementing right now is student teams that solve industry problems, right? We work with our industry partners in the future, identify a problem, shop floor, or whatever problem they might have and need resolved, assemble a team of students, and that will be engineering students, of course, but depending on the problem, we might add a finance major or a marketing major to solve that problem, more like a consulting team, right? And add additional resources, faculty or professional staff. For example, if the problem has to do with the implementation on a PLC on the shop floor, students are not certified to do that, and the company will not allow them rightly to touch it, right? But we have professional staff here that have done that for 30 years and are certified, so they can work with the students to make sure that it's implemented right and according to the law and the company specifications. The idea is the company setting. As they are being paid, there are certain expectations, right? That they need to dress professionally, they have to meet milestones, they have to present their solutions at different times and act as if they're full-scale consultants, professionals in the field, right? That gives them this experience before they graduate. So when they graduate, they had that experience already and can translate that directly in their jobs. And the company has the opportunity of an extended interview with these top students, right? They have 4 or 5 students for 4 months that they can observe, work with, learn about, and they would be very smart to make an offer to these students, right? And then when the student would accept that offer, they already know the company as well. So that matchmaking has happened, and there's no surprises at the horizon. And we hope that the 2 main problems that we learn our industry partners here try to solve is reduce the onboarding time, not have 6 months of extra training invested in an employee. So we hope to reduce that with this program. And second, reduce the attrition, right? Keep, like, the new employees will not switch after, I think the average is 2.5 years in some cases, but keep them longer, like 3.5, 4 years, right? That already would save a lot of money and effort and resources for the industry partners. So we hope to facilitate that through the center.
The hope would be a great one if that is achieved, because AI is screening a lot of those resumes that come in, and so if they're able to do that one-on-one, that would be terrific. And I think that would ease a lot of the discomfort the new employee gets, saying, I don't know if I'm going to feel right, and the employer doesn't know that fit that you're describing. And the interesting thing is those life skills, those life skill lessons that some parents aren't teaching at home, others don't know how to dress, how to act, how to perform, how to work with an older worker, younger worker, how those have to collaborate in teams. There's a lot of things that have to occur that you are able to learn in those couple of months, 4 months that you just described, I think are critical here. So when you talk about this bridging that academic learning with practical work, and you want to start doing that, what's the feedback then from industry saying, I'm excited about this?
Oh, tremendous. Again, a lot of that is industry driven, right? Industry, we talk with our partners at Scout, at Mercedes, at Train a lot, and get even smaller companies like CS has been very insightful. They all, and that's where the feedback came from, okay, reduce training time if possible by teaching students X, Y, Z, and then help us with retention, right? How can we do that? Can we hire locally? Can we hire students that are grounded in South Carolina so they don't leave us for a job in California at 2 years in, right? So industry has been very receptive, and we're working on some very innovative vehicles, how we can facilitate that with our partners. It's not set in stone yet, no signatures done, but there are some interesting pathways on the horizon, and we're in touch with, again, Scout Motors, the CTO of Scout Motors, Dr. Burkhard Hunke. He actually taught a class in our industrial engineering program last fall on systems engineering, brought in his engineers and gave the students first insights in how Scout Motors does their development. Then with Mercedes, we have an active research project with them supported by SE Competes with the USC Fraunhofer Alliance, which is a fantastic vehicle here in the state, I have to say. And their head of engineering, Nathan Bota, he also is very interested in helping us set this up, and he's a part of the advisory committee for our industrial engineering program as well, because they really want to integrate with us from day one to also help us give feedback. What should the curriculum entail? Like, when we teach quality management, what tools do they use? Can we incorporate some of these tools? Can we get a guest lecture in? So that in their internal training plan, when they know for onboardings, our new employees need to know quality management tool XYZ, they know when they hire from University of South Carolina Industrial Engineering, the students know that because it's in the curriculum, they are taught that, they have that checkbox before they even start at Scout or at Mercedes.
So looking at this, looking at the types of industry that you're working with, what are some of the challenges that you're now encountering? Because this sounds great, but you have to be looking at some of these high value opportunities, or also you're experiencing some challenges with it. It's not all roses coming right now. There's got to be some challenges you're concerned with.
Yes, of course. And a lot of it right now, we're in development. So right now we're still a smaller program, right? So right now we don't have that many students to place, so we have no problems placing our students at this point. In 2 or 3 years, if the growth continues and we have hundreds of students, there might be a bigger distribution of students and how proactive students are to go out there and work with companies, right? So there might be a placement challenge at that point. But I think...
Because right now, not to interrupt, but right now you have companies that want them. Scout is growing. They need as many workers as they can get.
Yeah, no, but on the flip side, I think what the biggest disruptor right now is AI. That is all over the place. And I guess there was some overhiring in tech happening over the last few years, and now AI is like levels the playing field a little bit in that space. In manufacturing, or not that industrial engineers always go into manufacturing, but that's my field, so I know that a little bit better. In manufacturing, I feel we still see an increase in opportunity, right? If that opportunity always matches the expectation, salary-wise and work-life balance, that is different, because, or that remains to be seen. Because when I hear often of the skill shortage and so on, it's always a double-sided sword, right? It depends. There might be skill available if you're willing to pay a certain amount, but not always. And again, like partners at Mercedes, where we're really transparent on that, they did a study. They pay extremely well, right? They're one of the highest-paying employer, and they still have to recruit actively because they need a lot of employees because they're growing, right? So I feel for our students, when we prepare them right, and with that state-of-the-art manufacturing curriculum that we set up, we have a mandatory smart manufacturing class. That's the only extra class that is not part of the core curriculum at most schools. I think we prepare them well for the economy in this state, right? And the U.S., probably southeast of the U.S., Texas included, where manufacturing hopefully will continue to grow when we bring back more of the value-added manufacturing here.
Some of that is the expectation. We have these high expectations, not realizing when they start to job hop, they've not realized what that might mean. And that's some of them, they think they go from one industry to another. It might be completely different, is what you're indicating a little bit. Unlike with manufacturing, is a different kind of industry, whereas others, they job hop from one industry to another. I think that's what you're indicating a little bit. Manufacturing has this need right now, and we need quality engineers in that. Some other industries say they have that need, and it's a different kind of, and that's why in automotive we see they're paying top dollar to get the best of the best.
They recruit from each other, right?
Exactly.
They kind of like say 50% increase. And,
you don't want to say they're stealing, but they're borrowing the best from the best. It is. It's a free market. They're borrowing the best from the best to get the best because the demand is there right now, and that's what's happening. But that's not always going to be there.
We both know it's a very exciting area to be in, and an exciting time to be in. One example you will appreciate is I got a call from a student when she learned that we started this new industrial engineering program. She asked if we can meet, and I said, so we met. And I think she was a senior in the business school in a finance major. She said, over the summer she did an internship and ended up on the shop floor and really enjoyed seeing stuff being made, right? And said, if it would be advisable if she takes industrial engineering as a second major, it would extend her studies by a year. But she really wants to work in that area in the future because it's so exciting and it's so fulfilling to see things coming out of at the end of the line that people will use. So she's now one of our top students. So she decided to join our program to switch. I think her finance major will come in really handy further down her career, but she wanted to be in the manufacturing area, and there having an engineering degree is just a very good pedigree.
But I think that's indicative of today's students in general, not just being focused in one area. having more expertise in many areas. I think when we look at that, I realize what you're saying, what's happening there, but that is very strategic in her part, understanding where society is going to be. There's going to be these peaks and valleys. And I think that says to her, look, you're going to be very educated here, but now when an industry takes, and we've seen it in manufacturing for many years, we've seen it in construction, we've seen it in logistics, when we see those, her needs are going to go up here and go down, and with AI, we don't really actually know where the demands are going to be at what time. Are you seeing that same challenge a little bit?
I myself, I have a business degree and engineering degrees myself, so I was torn between the two worlds as well. And I think industrial engineering is a beautiful intersection where you can go more into the higher level business area of manufacturing or systems. I should not just talk about manufacturing, right? Industrial engineering is more than that. Or you can go really deep technically, right? And students, also students that take classes in arts and sciences, which I think is fantastic for mental development, to be creative and problem solve. On the research side, I work with a philosopher quite closely in Buffalo who is an ontologist, right? So industrial ontologies, he's a philosopher, but the thinking and structure of thought translates. So I think we should not remain in our buckets, right? But teach our students, these are the opportunities, and now shape it yourself.
And that's a really good point, because the long-term vision, I think, and I don't know if this is what you're thinking, is the long-term vision then for the center to then impact education and industry engagement in more ways than just what you're doing? Because smart manufacturing, or if we talk about industries focused in how it's going to, we don't really know in general what our needs are going to be. Absolutely. We don't know what the next big innovation is going to be, the next big smartphone. We don't really know what that next big thing is going to be that's going to revolutionize the automotive industry. We think we do, but we really don't. We didn't know the iPhone was going to change all of our lives. It wasn't the iPhone, it really was all the apps and the way we incorporated all of them. Maybe we did, but until all the apps came about, we didn't know that people were going to think that was an extension of their arm. I don't know. Look at everything else, TikTok, everything else that's emerged from it. But I guess the point I'm making is healthcare, or all the other things and cures that are coming about from all the other things that we see through, and you and I have had this conversation. I'm a big believer in data and IoT. You can't have AI without IoT. But all the things that you're doing, if we teach younger generations to think about what next big innovation, I think we're in this calm before the next big great innovation. We're not there right now. It's not the internet yet. It's not electricity. It's not the light bulb that came from electricity. I guess that's what I'm saying.
I fully agree, and I think it really aligns with how we defined the industrial engineering program, because it's probably one of the leanest, no pun intended, programs in industrial engineering that you can find, because it is so new. So we had a chance to go back to the drawing board and design it really with only the core that is needed for accreditation that is required, and the rest is free play, right? So students can make each of their curricula their own, with a lot of technical electives. When they want to go into healthcare and say AI in healthcare, they take 2 classes in computer science on AI, and a class in public health on whatever they want to do in healthcare, right? And then they have the industrial engineering degree with that emphasis, which makes them very marketable in the medical space, right? A lot of hospital quality managers are industrial engineers. On the other side, when we look at what industrial engineering is supposed to do, right? It teaches methods and tools to adapt, to make stuff more efficient, to solve problems. And I think when we don't know what the future will be, but the future will hold problems and challenges, and we have to find methodological ways of approaching them in a data-driven way. Right? And that is what industrial engineering is about. We collect data, understand the problem, test it, evaluate it, see if it solved it, and then move forward.
But I think about like a Siemens, who has the most advanced equipment in the world for solving some of the scanning or whatever, and producing equipment and manufacturing for that. Maybe that comes out of that, but it's data that led to that, or any of those other things that might come out of that. Is that when you think about applying real-world problems to real-world solutions in a manufacturing, an advanced manufacturing environment, aerospace, whatever that might be, is some of those kind of things that you're maybe haven't thought of, but you are thinking of, I guess is what I'm saying.
Yes. So and then now I would switch a little bit from the education teaching side to the research side, because that's a topic I'm very passionate about. I think when we talk about AI is in the news everywhere, right? And it's an extremely powerful tool. But when we talk about AI in manufacturing, we still have to realize that the data picture looks very different from what is accessible, how rich it is, how biased it is, how unbalanced it is, how incomplete it is, right? Because when we work a lot with our computer science colleagues, and it's a great collaboration because they really drive innovation on the algorithmic side. But that's not the problem in manufacturing. The problem in manufacturing is, can we get a data set to use some of these advanced algorithms? In many cases, the answer is not. Because tell me, a company that is successful, how many bad parts do they produce per 1,000 pieces? So that's the balance, right? Train an algorithm on 99.9% good parts, and that's a bad company with 0.1% bad parts, right? Train an algorithm on that, it will give you always an accuracy of 99.9% because it will just classify everything as good and it looks fantastic, right? But it's useless. And then when you pull data from a system like ours, or any system, right, a Haas machine tool, you rely on that MT Connect protocol is installed correctly, right? It's not in many cases. So you have missing values, drop packages, right? Synchronization issues, clock issues. And then you have the CSV data set, and that's when often you have that A data set that you download somewhere that somebody gives you, and then you hand it over to an AI specialist that has no subject matter expertise in manufacturing, and they take it at face value. And it might be imputed, there might be missing values, and they just use an algorithm to fill these spots or so, right? And then they draw conclusions, get a certain numeric out of it, and it looks good, but is it really trustworthy? Can the AI base a decision on it that is life or death on a shop floor in some cases?
But if they've been given bad data, that they don't understand its history of the data, isn't that what we're using now by saying the data is clean? But how do we ever know when this is the data we've started with by not understanding the history of where the data's originated from?
Exactly.
How do we get the students to understand where all this data's come from? How do we teach them to question, challenge, when sometimes we are told, just do it the way because I told you to do it, without understanding how do you extrapolate the good from the bad data, and understanding that you have to look at this a very inquisitive way without a disruptive way, but yet be transformative. I guess a lot of questions.
I have to tell your readers, viewers, that we didn't set this up. This is totally natural, right? Because this is a wonderful pathway to the smart manufacturing class we are teaching. Because the class has 3 projects. The first project is very simple. The students have to take a Raspberry Pi, a sensor kit, outfit it, write the code to collect data, and then basically collect data in a fridge with the door open, humidity, and so on, and then plot it. Basically to show the pipeline from physical system, something happens, how does the data look like, what can go wrong, a pin is bent, or the power is out, or real data, right? To show them, hey, data is not just emerging out of thin air, right? Data has to be collected, and in this collection piece, where you put the sensor in the fridge, is it close to the door, is it in the back, is it on top? It has an impact, right? It's not just temperature data as the ground truth. It depends, right? Context matters in your analysis later. So that's the first project. The second project, then we look at visual data, inspection data, where they then get a data set, but already have that experience of collecting data originally. They can augment that further, and then we show them how to work with a bad data set, right? How to clean it, how to balance it, how to use methods to augment the data set that does not allow you to train an algorithm. As a second project. The last project is a data set that is impossible. I hope my students don't see that, because otherwise they know how the project works, but it's more of a business problem in the end, right? When you take a step back and look at it, all of a sudden you might see it, but when you try to just throw an algorithm at it, it will not give you any results, and that's on purpose. Because we are so trained of, oh, we have a good algorithm, it will give us results. But we had a project with a company in Indiana, 1.5 years, great project, great success in the end, during COVID, so that made it a little more complex. But the charge was to save 15% of energy during a grinding operation of a 1 meter diameter gear. And we went to try to do that, outfitted the whole machine tool with sensors and energy meters and power meters and so on. Got the data, pulled in an Azure database, analyzed it, tried to use a LSD, a modern tool, because we wanted to use a modern tool with it. realized we don't have enough data, right? And at the end, we were able to save 41% of time and 37% of energy, which is over $100,000 a year of the company. And now looking back at it, I could have solved that. Now, when I have a project like that, I can solve the same project without applying any computation, just by visualizing the data we collected. And we save probably 30% of energy just like that. Because now I understand what the data means. Right? And we used a very simple neural net at the end, because the solution was right there. So it's not always a complex algorithm that defines a good solution, but the problem defines what the solution should be.
When you get your students and they come in and they're excited, and we've discovered since COVID that a good portion of the students came in with this 60% real knowledge of reading level. Then it dropped down to 30%, and now you're hoping to improve that. How are you finding the students' abilities to really perform the tasks that they should be able to, as you're describing here, that have this proficiency to be able to do the things that you're describing? Because now they have to have initiative, they have to have drive, and a real commitment to want to solve this. It's not only now just being able to solve the problem, but they have to be able to solve problems that before they weren't able to do. Now they have to take initiative that requires a whole different thinking process of saying, we're just going to A plus 1 plus 1 equals 2. Now I've got to think about how to solve problems differently than ever before. And that initiative has to be self-initiated. Whereas in business, we say, okay, we're going to go take a course and we're going to do this. Now in school, you're doing that, but we have to constantly teach ourselves. We have to have businesses teaching them. It's not necessarily going to be that way. With AI, you have to want to keep teaching yourself. You got to keep wanting that drive. How do you get these students to want to know to do this, to be competitive, and to be that next leader?
That's an excellent question. Like we try to do that. A student, like typically the intake has a certain distribution that is, when you have fantastic students, you have that distribution. When you have regular intake, that's normal. So we have fantastic students. I think South Carolina has the #1 honors college of all public schools in the US. So these students are exceptional. You don't have to worry about them. They have that initiative from the get-go. You have to hold them back and say, like, slow down, and they're great. And most of our students are really motivated. So that's the wonderful thing. However, I think there's multiple factors, and I'm not a psychologist, so I don't know why, but I think COVID played a role, and then of course TikTok and quick cycles of news and how your brain is flooded with information probably also has something to do with the concentration. But look at how they interact, especially freshmen, because that's when they transition from the more 1 plus 1 is 2 to hopefully being independent thinkers, right? That transition is hard. They're pretty young still, and they transition from this more secure environment to the big state flagship school. And that is one reason why I really was so excited when we were able to hire John Petta as a professor of practice, because he teaches the freshman intro to industrial engineering class. Because in my mind, that is probably the most important class we teach in the program. Because in the first year, a lot of the students take classes all outside of engineering, like math and social studies and Carolina Core, and some of them might forget why they want to be engineers, right? Because they don't have engineering classes, because they have to take all basic requirements at the beginning. So intro to industrial engineering, how we design the class and how John teaches it fantastically is throw problems at them, give them methods, and then let them run with it and present them. Like last year, the first time it was taught in fall, he took them to the Russell House food court, and each team had one of the eateries assigned to them, and analyze the process, use industrial engineering methods, apply them, come up with a solution, present the solution, say what impact it will have. And within 1 month from high school to 1 month in the university, they presented. I went there to see what they can come up with. I didn't have high expectations, to be honest, because it's hard, right? They didn't have much background in these methods and all. And they did fantastic. Like, it was wonderful to see how they were engaged, how they used the methods correctly, and how they came up with solutions where you think, like, they should do that. Yes, it's so obvious. Like, why is that food standing there so long when they could do it like this, right? And you could see how the students were excited about it because they saw the impact of what they resolved. Right? And I think that's a very long answer to your short question, but I think showing them why they should do something and showing them how they can be successful and being creative. finding solutions and applying methods that we can teach them to real problems that understand and that mean something to them.
So that predict, deploy, monitor, all of those things that we would say is happening in analytics is the same thing that they're happening within that, whatever the vertical might
Yes,
be.
exactly.
Looking at all these now, you talked about how this will impact work. How will this impact then the state itself in South Carolina and in the future? You've talked about growing from 60 students, 40% growth. That's what we started the conversation. How will this then overall impact the state and then impact other states that have to help the future of work in general?
I just saw the statistic that South Carolina is the highest net growth state in the country last year, I believe, right? So the state is growing, and a lot of it, in my opinion, has to do, again, being biased, with the manufacturing growth here, right? There's good jobs here with good companies that invest in facilities, but they also invest in people, right? And I think that will draw how we contribute to the state's success. The companies came and said, we want more industrial engineers. That's what we're delivering right now. And when companies know they can get that, the next line for Scout or the next line for Mercedes or for BMW, they might say, hey, yeah, we stay in South Carolina and add to the facility because we can get quality, hardworking, educated people here that want to stay, right? So I think that's my vision for how the program really can contribute to the state's success, because the companies want to hire local people that are grounded here, that stay, so they don't have the retention problem. They want highly educated individuals that have drive, that know what, that align with what the companies want to hire for, and that's what we're working with the companies to deliver. And when we can deliver more, the companies have an unlimited amount of work to do, right? Because they have choices. They can go to Texas, they can go to California, they can go to Mexico or Europe or stay in Europe. But right now they choose South Carolina, and we have to make sure that we have the pipeline that continues to be the case.
Is one of the challenges is the fact that it is a military state, it has a military base, and that a lot of the residents here serve in the military, then they're here, then they have to leave. Does that create a challenge at all?
I don't believe so. I think that's actually a good thing. The next year we will host the Defense Industrial Base Conference here. We plan for that here in Columbia, because I think the strong manufacturing footprint aligns very well with the military culture. Not just because of the arsenal democracy that we also need to keep in mind, because all these companies might be able to deliver needed parts for the defense industrial base at one point, but also the mindset. I think hiring veterans, hiring ROTC students is the smartest choice you can make, right? The people have shown that they can deliver, that they're reliable, that they're dedicated, hardworking.
What haven't we talked about that you would like to talk about?
We talked about a lot of things, right?
We did,
Carolina
right?
No. No, I think what also really stands out here, what I'm really proud of, is how our team came together here, because with the transition, some students stayed back in old school and so on. So now we're really coming together here. And what I'm really impressed with here is the undergrad research culture at USC, which I think I have not experienced anywhere else. In my first class that I taught here was manufacturing processes. Two students directly after the first session came up to me and asked questions. I thought, okay, that's great. Next session they came and applied some of the stuff I talked about independently. They said, look, I tried this and the G code, that's fascinating. And the third session, they were working in my lab and made really interesting, like one of them is still working with me right now. We were talking about patenting a solution that he came up with based on the class, right? And I think that culture is just fascinating. So I think this is the outstanding here.
That's what you want. You want that excitement and enthusiasm to say,
you don't have to
create and
motivate
innovate.
them, right? You just give them the tools and the support and integrate them in a team. And then the other student over there, Wade, he joined us last summer. He did a summer research internship in Alabama on blockchain. And I have a project with NSF on federated learning and blockchain, right? To try to distribute learning and get the data together to build a meaningful model. And we don't have much experience with blockchain at that point, because that was more like the stretch goal. You're more on the algorithmic side and the data side. But we thought it fit well together, right? That was the project. And then Wade, the student, came with that blockchain experience but no manufacturing background. And he's an integral part of the team now. He's an undergrad, already has 4 or 5 papers now, some as a lead, some as a co-author. And that is just wonderful. I just try to keep him, but he already has 2 offers from exciting companies, so it's very difficult to. Our students are so good; it's hard to keep them for graduate studies.
That's the good news. That is the good news. So, final thoughts. How do we wrap up this amazing conversation? What do you want to leave students who are inspired to do great things?
I think South Carolina is a great place to come, both for studies and for work. And what we're building here is special, and I would love to have more students to join us, for more companies to come here and learn about our students, get in front of our students, right? We can have guest lectures, we can have events with companies to really get the students involved and know what companies are looking for, because we want to help our company partners to educate the students to their need, and vice versa. The companies can see what our students can deliver and then hopefully be good partners.
Thorston Wuest, Director for the Center of Industry Solutions and Professor at the University of South Carolina. I've enjoyed this conversation as always. Where can our listeners go to get more information on what we just talked about and to get in touch with you?
Peggy, likewise, as always, and hopefully we can do that not in 4 years, but maybe next year or so, right? The university website is a good starting spot. I have my own website with contact information and papers. It's smartmfg.info or my name, first name, last name.com. That is always a good starting place.
All right, Thornton, thank you so much. All right, listeners, that is all the time we have for this show today. Check out our website and subscribe to everything we do. Share your thoughts with me on X at Connected World, or follow us on LinkedIn and YouTube. Continue the conversation there. Please check out our website at connectedworld.com, or show website at thepeggysmedleyshow.com. And remember, we broadcast live every Tuesday at 12 p.m. Central, and we launch our podcast and our YouTube channel, which goes up every Thursday. All right, this is the Peggy Smedley Show, your voice for our connected world. And remember, with great technology comes great responsibility. That is a